This is MAC 1105, Section 1.5, Part 3. What we've been doing in the last two videos is solving quadratic equations. This is the fourth method for solving a quadratic equation, and that is to use the quadratic formula. Notice the term quadratic formula will help you solve quadratic equations. And a quadratic equation is something in the form like this, 4x squared minus 5x plus 3. The formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, all over 2a, not just this part over 2a, but the whole thing over 2a. You need to memorize that. The quadratic formula is very powerful because it will work on any quadratic equation. If you watched the first video on this section, I told you that not everything factors. Everything can be solved with the quadratic formula. Now, to do that, everything must be on one side in descending order and equal to 0 before you name A, B, and C. So I would suggest you write out the formula. Write out the equation. It's already equal to 0. So we can go straight to naming A, B, and C. A is the coefficient in front of x squared, B is the coefficient in front of x, and C is the coefficient, or is the plain old number at the end. This you don't have to do, but I think it just helps you, especially in the beginning, start stuffing in. So that's our formula. So we will say x equals, and I'm going to write this out really, really picky the first time, and then you do what you want. Negative b, which happens to be negative 5. Yes, I know negative of negative means we could have just put 5 there, and that's fine. I'm just showing you every little step. Here's something important. That says b squared. If you just put negative 5 squared like that, you're going to have a problem. It is b, the whole quantity squared. So when you're dealing with b being a negative, you need to put parentheses around that b value. Negative 5 quantity squared minus 4 times a, which is 4, times c, which is 3, all over 2a, which is 2 times 4. Clean this up. Minus a minus is a positive 5, and yes, we could have done that right in the beginning. This part under the square root, you can enter directly into your calculator. Don't enter the square root sign, just parentheses. Negative 5 squared minus 4 times 3, and that will give you the square root of negative 23, all over 8. Now we have to clean that up a little bit, and that is, remember the square root of a negative produces an I, so there's an I that's going to come out of this, and this is 5 plus or minus I, radical 23 over 8. And you can put the I in front or the I in the back of the square root. Just be sure if you put it in the back that you spread it out enough on MATLAB so it doesn't look like it's underneath the square root sign. And of course, MATLAB would expect you to enter 5 plus I radical 23 over 8, comma, 5 minus I radical 23 over 8. Here's another one that is not in the proper form to start with. Remember, everything's got to be on one side in descending order equal to 0. So bring the 2x and the 7 over. Will give me 4x squared minus 2x minus 7 equals 0. So it's got to be in that form before you name A, B, and C. A is 4, B is negative 2, C is negative 7. So x equals, negative of negative 2 is just 2. That's all I'm going to put right there. But I am going to put negative 2 in the parentheses squared, minus 4 times a, which is 4, times c, which is negative 7, all over 2 times 4, because 4 is your a. And then we will clean this up, typing all of this as you see it without the square root, because if you use the square root right there, you're going to end up with a decimal, which is not what we want. So we'll type all of that in, and that gives you 1/16 all over 8. We need to do a little factor tree on the square root of 1/16, so 1/16 breaks into 2 times 58, 2 is prime, 58 breaks into 2 times 29, those are prime, so we're looking at 2 plus or minus, we have a pair of 2's coming out and a 29 staying in, all over 8. Now from here, there's something I call the triangle trick. We have to do some simplifying because this number, and this number all have a common factor of 2. Here's my triangle, that's why I call it the triangle trick. I need to factor a 2 out of each of those. So 2 goes into 2 once, 2 goes into 2 once, 2 goes into 8 4 times, which gives me 1 plus or minus 1 times the square root of 29 over 4. Now the reason I wrote that 1 is just to emphasize that you are dividing by 2 and there is a coefficient there. But we don't need to write that 1. We do need to write the 1 in front. So this is 1 plus or minus the square root of 29 over 4. This third one is not in the proper form either, but all I have to do is subtract 3 from both sides. I'm going to get a little lazy here and put minus 3 equals 0. Name my A, B, and C. A is 3, B is negative 8, C is negative 3, and start plugging in. X equals negative B, so negative of negative 8 is 8, plus or minus the square root of negative 8 squared. I'm going to put that in parentheses so I get the correct sign there. Minus 4 times A, which is 3, times C, which is negative 3, all over 2 times A, which is 2 times 3, which makes 6. So that's 8, plus or minus. This works out to be 100, all over 6. Now this time, we've got a perfect square, so the square root of 100 is 10 over 6. This is like what happened with taking the square root method and with completing the square, and that is we have no I, we have no radical left, so we have to do high road and low road here. The high road would be 8 plus 10 over 6. The low road would be 8 minus 10 over 6, and then clean up your arithmetic. 8 plus 10 is 18 over 6, which is 3. 8 minus 10 is negative 2 over 6, which reduces to negative 1/3. Be sure you reduce any fractions. So those are 3 examples with the quadratic formula. As long as you, A, memorize the formula, and B, do your arithmetic correctly, this is a pretty easy process. I want to say a couple things about that triangle trick. Number 1, you need to have a common factor here, here, and here. It does not matter what's under the radical. You could even have an I instead of a radical, but you must have a common factor for all 3 of those. Do you have a common factor between 8, 9, and 12? No, you do not. So you can't just do some canceling with the 8 and the 12 or with the 9 and the 12. It must be the same common factor for all of them. So this one right here cannot simplify. That's it. Now this one, I chose an I to show you it's the same idea. Do you have a common factor between here, here, and here? And the answer is yes. 4 goes into all of those. So 4 into 16 is 4. 4 into 12 is 3. 4 into 8 is 2. So this is 4 plus or minus 3i over 2. Now, for the i's, we need to also separate this into 4 over 2 plus or minus 3/2 I. So to clean this up entirely from Math Lab, 4 over 2 is 2 plus 3/2 I, and the other is 2 minus 3/2 I. Now, in conclusion of the last 3 videos, we are solving equations either by factoring, by using the quadratic formula, square root property, or complete the square. Now, that's not the order I taught you. The reason I put it in this order is because both factoring and quadratic formula require us to put everything on one side in descending order equal to 0, whether you're going to factor it or use the quadratic formula. The idea on the square root property is that you have x squared on one side and a number on the other. Now you could also have for the square root property something in parentheses squared equal to a number on the other side. That's taking the square root. And then of course complete the square is that 4 or 5 step process, but you've got to have x squared and x on one side and have the number on the other side.